So, good morning. Hello. This. We'll talk about that. My presentation. Louder. Okay, fine. So my presentation will be further illustration besides the topic that I completely disregard proper presentation rules. Sorry. Something I wanted to say is that I'm really grateful for all the, what shall we say, for the treatment that I've been given here, be it the books or the introduction or mentioning my name or pointing me up with a finger. It feels really weird, I have to tell you. To some extent, when I see my books, I don't quite realize that, I wrote them. And since I was just looking at the hash book thinking, who's the idiot that wrote all this mess? That's a lot of work. Whoever did it, that was not me. So, seriously, thank you. I really appreciate that. Thank you, thank you, thank you very much. Thank you. Wow. All right. Well, hopefully this will live to that expectation. All right. So, basically, that fast. Okay. So let's take a look at ESUG. I'm sure everybody's familiar with ESUG, particularly you. So, as you know, basically what happens with ESUG is that when we run a test, we get this test result that has these instances of test cases categorized by passes, failures, and errors. And basically, what that is telling us is that a particular test selector costs something along the lines of self-assert true, and failures called something along the lines of self-assert false, and the other ones just blew up. Now, this may work okay in most circumstances, but I was faced with a problem because I had to write a test tool for hash functions. And at that point, I realized, well, but this doesn't really fit anymore because this is more or less how the hash analysis tool works. So the hash, you run some calculations, and the result you get is much more rich than basically true, false, or exception. Because now you have that a particular data set was analyzed with a particular hash function, and that goes under statistics, and here are the statistics, and so on. As you can see, that the result is much more rich than the ESUG result. So I wrote a tool for this, and we'll begin the talk by seeing what I saw with doing that. So what are these statistics things? Well, the statistics are calculated by this calculation objects. I'm not going to go into details as to what those are, but to give you an idea, that's what's going on. So different types of calculation objects calculate different results about this hash function applied to a particular data set. And the thing is, well, the distribution calculations are interesting because there are many ways in which you can calculate these things. For example, you could go and accumulate your hash buckets, counting, well, what objects happen to cause a particular hash value to appear. Like, for instance, over there, D1 and D2 cause the hash value 1, and D4 hash value 4, and so on. But also, well, that is interesting to see what objects cause these hash values to appear, and that's how you can fix collisions and all that. Well, if you're not interested in that, then it's easier to just keep account of small integer counts. Then you don't have to keep another collection, and there's less allocation and so on. And the next thing would be to avoid to have to write the same calculations twice. One for this data structure and another one for this other data structure. Because sometimes you just want it to go fast. So instead of doing that, something new appears that is not present in ESUG. And this is an evaluation context. The reification of this object is very important because it gives the opportunity to express, to make explicit how is it that a particular test is being made or is being run. In ESUG, we don't have that because it's an interaction between test suite and test case, and so on, and there's code in both places. So for instance, test case, which should contain tests, also knows how to run them. Maybe that shouldn't be the case. And the other part that, does all the collection of results, that is somewhere else. And there's all this, the collusion, it's so intermingled like this. So when this object appeared, to me it was like, oh, okay, fine, because now what I can do is just write the distribution calculation once, and then have this arrangement here where the distribution calculation is told, well, give me your results in this evaluation context, and the distribution sends these messages to the evaluation context. So give me these bits of information. And because the evaluation context can hide, how the hash buckets are structured, then it doesn't really matter what data structure you're using. Actually, the hash analysis tool, furthermore, not only sometimes keeps, a count of small integer count of occurrences, but also uses a hash bucketed dictionary implemented as a subclass of dictionary. And all these details are completely hidden from the distribution calculations, and they don't care. This is important, and we'll see how it plays on later on. There's another issue that came up with this tool, and that is, well, for example, right, so I wanted to have a drop-down of what data sets were available, and so I have this hierarchy of data sets, blah, 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 whatever, and this is how the class hierarchy looks. Okay, so this is how it looks in the tool. So you can see, class hierarchy over there, data set blah, data set this, data set that. That's very nice. The problem is, that's not the only kind of data set you'd be interested in. And it comes into play in this. So in the UI, that tree is built like that. So you can see, send subclasses. What's that? Ah, my friend, I shall read. Sorry, Tudor, you're right. So, I am wrong, yes. So, what's going on there basically is that if you have a class and you ask it for its subclasses, and that's how you get the trivial children. And that's how you check if it has children or not. And the children are some sorted subclasses off. And basically it's just you have a class and you walk the class hierarchy, and that's how you make a tree out of that. Well, but it's interesting sometimes to sort data sets in another way. For example, for implementation purposes, it may be interesting to organize data sets in a particular way. For example, here I have some string data sets that are word lists. And here I have some other string data sets that are repetitive sequences of something. And here I have another string data set that are sequences of 4 letters. And because from an implementation point of view, they don't share much code or they don't behave very similar, then there's no common superclass that says, well, these are all the byte string data sets. And that makes it difficult, because then if you want to find the particular data set in the class hierarchy, you have to scroll up and down and so on. So it's kind of nice. It would be kind of nice if there was a tree that told me, well, these are all the string data sets. Here you go. These are all the array data sets. There you go. These are all the integer data sets. There you go. But the problem is, well, there would be some root class in this tree of some sort, but it doesn't exist. And the byte array superclass, for all those, well, it doesn't exist either. And the same for the string ones. It's like, well, what's going on here? And how am I going to mix and match all these things? All those problems that I just talked about. See, delete slide for the next version. And then there's something called ad hoc datasets. When I first wrote the tool to make an ad hoc dataset, like for instance, to get all the instances of a class and hash them all, it was necessary to create code. Now Travis, a coworker of mine, said, well, but the all instances data set is kind of common, so it would be nice if you didn't have to write any code. So, so that now there are ad hoc data sets, which are instances of a data set that collect instances of all classes or have an arbitrary list of whatever you want. But again, now there's more hierarchy problems, because where do these things go? They are not even a class. They are an instance of something now. So, what am I going to do now? And to top it off, then there's the ability in the tool to, let's say that you have a hash collection, and you want to see, well, is it behaving well or not? So it would be nice to get this hash collection and stick it in the tool and have it work. In other words, if you have a set, the data set would be all the objects in the set. If you have a dictionary, it would be the keys in the dictionary. But again, if there's this hierarchy tree that is being used to display things, well, how does that fit? Well, first of all, what's a superclass? And, where am I going to fit all these things? Solution. And now, see, now there's something that doesn't work again, but it's okay. All right, so this is the solution, right? So there's this class over there. It's called abstract dataset meta class. And and there's this new message that answers self. Does anybody notice anything funny here? Well, yeah, that's on the instance side. What's going on, right? It's new answering self on the instance side. What the? Okay, what's going on here? So what's going on is that since in Smalltalk everything is an object, then classes are objects, and since polymorphism applies to all objects, then polymorphism applies to classes. So if I don't have the classes I would like there to exist, I will create a class called meta class, the instances of which behave like the classes I wish I would have, but I don't. Was that too fast? Hopefully not. All right, yeah. So basically, what's going on is that the class of class is a meta class. So this is something that behaves like a meta class in that its instances create something that behaves like a class. That's why there's new on the instance side of meta class. And these are regular classes, but because of polymorphism, I can pretend to have the classes I cannot have, because, for example, I cannot go and just modify all the data, all the class hierarchy just because I don't have the classes I have or I want. So how does that work? So, for example, there's a message subclasses over there, and you can see that in subclasses there's a collect that's creating more meta classes from the list up there. So that's how you get to rewrite the class hierarchy all the way you want. Because all of a sudden you can, well, since I create all these classes all I want, then well, the subclasses are just instances of the same. More of the same, so another meta class has different subclasses, and that's perfectly fine. Eventually, oh yeah. so now there's eventually some meta classes are going to have to pretend to be an actual class, because so far we've been just creating meta classes that are just there for classification purposes. And for that there's this message class to impersonate. So that's actually an instance variable. And then because you have that a class that you are faking, you can implement things like browse as well. The class I'm impersonating, well, browse that. And you can also do subclasses. And eventually, there's a class that actually represents one of these instances that represented, a hash collection in the hash analysis tool, or a collection of all instances of something in the hash analysis tool. And for that, there's this if meta classes with. So in this tree, that bottom meta class that you see over there is called leaf dataset meta class. Well, that's how you create a leaf. A new, in this case, doesn't create any instance because the instance already existed. So new just gives me this self-dataset that was provided by the previous method. So if I have dataset, well, that would be a set, a dictionary, a list of things. And in this way, one gets to create all the classes one doesn't have. So, well, but does this work? Is this really useful here? Well, yes. There is the dataset type hierarchy with the dataset sorted, by annotated method, by the right byte string, byte symbol, or value date. There's the ad hoc dataset hierarchy, so to speak, again with classes that don't exist. Now let's add some stuff to that. So, for example, if you inspect Smalltalk, you get this inspector on the dictionary, and then there's this menu item that says adopting hash analysis tool, and that brings the Smalltalk, the dictionary, into the hash analysis tool as a dataset, as a leaf meta class, the instance of which is that dataset. And we can also do other things, such as, for example, you can add an ad hoc dataset, which could be the all instances of association, and it lives there in that lovely tree, all with pretending to be subclasses and everything else. And it works, you know, you get the results. So all that is good. So this was what I learned with the hash analysis tool. And then I didn't consider this to be much related to the unit, you know, because this was much like custom work. But there was more. I wrote, over many years, extensions to this unit. I started with this unit validation, and which Leandro talked about here last year. And I also did this unit benchmarks. In order to do this, I'm just going to go briefly over them in just a moment. In order to do this, I had to have a refactor of this unit that was more amenable to change. And well, what do we mean by that? So I have this unit VM, and that's a refactor unit. So what kind of changes are we talking about? Well, for example, there's cases in this unit where that test suite class is repeated in all these methods, so it's referencing every single of these methods. Now, that may not seem like it's too bad, but the problem is that then you cannot refine by subclassing easier, or in an easy manner, because now let's say that for unit validation I need another validation suite, another class of this suite, perhaps a subclass. Well, because that class is referencing all these methods, then the way to fix that would be to copy down the whole method. Because there's not a level of indirection there that allows change to occur. So some of the refactorings are along these lines, impose a single reference to globals and single reference to constants, such as, for example, the selector pattern. And also this. Do you remember run case? In this unit, there's a two-level nested undo handler for running a case. The one thing that, if I remember right, the one inside is for failures, and the one outside is for all the other errors. Well, the thing is, with the unit validation, there are more exceptions, and with this unit benchmark, there are more exceptions, because there are different kinds of failures. You have validation failure, or benchmark measurement, or benchmark expectation. I'm going to go through those in a little bit, but just to give you an idea, there's more exceptions. And with the original method, what I would have had to do would have been to add, undo many times. But the worst part of it all is that I would have had to override a unit. And again, I cannot extend by subclassing, I cannot extend by just adding new things. I have to go and touch the code, and that's something I'd like to avoid. So this is a approach to deal with that, and that is to do double dispatching on exception handlers. So when any exception that is interesting occurs, then just tell the exception, you occurred for this test case in the context of self. Now, and you see here how there is some sort of an evaluation context object here that is not an instance of something. But you can see what's going on. There's information about what happened where. And the where doesn't have an object right now. And that's why all these selectors appear and all these contexts is being passed around. So you can see that, yeah, it works. But we've seen different. So how do the polymorphic exception handlers work? Well, for example, if an error occurs, that's the implementation for error, right? So if an error occurs in a test case, then hey, the test result, record this test case as an error. And we know we can do that because we are exception error. And since we know who we are, we can make that decision. And then we just say, well, just fail the whole thing. This may give you an idea. Now let's take a look at how validation works. And this is just very brief because we talked about validation before. This is just about the mechanics of validation in terms of a unit. So for example, in a unit validation, there's instances added to test case. So for example, there's that object, there is an original object, and all these other variables that are used to implement different features of validation. So that's different. That may not be too bad, except that now we are raising new exceptions. So this is one of the new exceptions I was just talking about. Now with polymorphic exception handlers, it's a simple matter of adding occurred for test case such in the context of whatever. But with an undo approach, I would have to add another undo handler in some sequence and hope that the sequence overall is okay. What about benchmarks? Well, benchmarks is another one of these things. So I was writing the mentoring book, and for the people that have read that, there's all these lovely tables in chapter 3 for the performance of character array match, the string match for this in VisualWorks and others. So this is the original workspace I did for the book. I did to make the tables. You notice what's going on here? So there's all this copy-paste, and all these lovely tabs, and blah, blah, blah. You know how many do-its, and actually, you know how many print-its there is, and doing it many times, to make sure that the result is okay? Really? You know what I think about that? That's right. Yeah? Alright, fine. So I did that for the book. That wasn't such a great idea. So I said, well, maybe it would be better, since these are tests also, it would be better to adapt this unit to do this too. I have done this unit validation, then perhaps I can adapt this unit a bit more and have it do benchmarks for it. This is the benchmark test case. And the thing that is particular about benchmarks, besides these pretty green things that are for reporting purposes, is that there is a selector for setup instance variable right there. And what that means is that in the same way that the tests before were run with many different algorithms, it essentially was the same test. And you have a pattern and you have a string, and basically you send match, or match this, or match that implementation, or this implementation, and that algorithm, and so on, and many times and so on, right? And you have all these pairs of patterns and strings. Well, the idea is, well, the code stays basically the same. What changes is the input arguments to it. And for that, I decided to add multiple setup selectors for each test. So in benchmarks, what happens is that, whereas in a unit, each test runs setup, run the test, tear down. Well, in benchmarks, there's multiple setup selectors. So you have setup A or setup 1, 2, 3. So running a test means setup 1, test, tear down. Setup 2, test, tear down. Setup 3, test, tear down. And that for all the tests. So now you get a multiplicative pattern here, because you can arrange this to be a Cartesian product. So, and again, right, these are new measurements now. These are not just, pass, fail, and error. Because, well, for instance, let's say a benchmark fails. Well, yeah, but by how much? Did it really fail, like 10 times slower? Or, it was like just a smidge? Or if it passed, by how much? Is it just 2 times faster, 1,000 times faster? What is it? So then we have more exceptions that raise different kinds of results. And as you can see, the poor test result object is getting bombarded with more instance variables to list all these things. More exceptions. Something interesting in benchmarks, for instance, is to say, well, this should run faster than that, and by this much. Now this is another measurement, and another result, and another exception. So imagine, undo, and blah, 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 blah. So this is how the new implementation for that ugly, yes? No question? So this is how the new benchmark test case looks for that ugly workspace that I showed before, the one about, duh. And really, when you look at this, you can't help go like, well, duh. Right, so here you can see all the setup selectors. And you can also see that this test case has 2 instance variables, the pattern and the string. So what's going on here? Well, here's a setup. So basically the setup says, here's your pattern and here's your string. And that's a setup selector, and I think there's like 56 worth of those. So, okay, and now it's also interesting, now that this is in code, it's also interesting to refactor even the setups, because a particular characteristic of this is that it's interesting to test with the same case and with different case. So instead of writing that thing twice, you can do like this. So when there's a mixed case test, the setup is, well, set it up with the same case, and then just make the string uppercase. And now you don't even have to write all these things twice. This is great. Here's a single message to test a single implementation, as opposed to all these do-its. Basically, it says, here's the tag for the reports. This implementation is going to be called BW. And here's my pattern, and here's my string. Measure that. The message is stopwatch, stopwatch. So measure that. Now we have one measurement test with 56 setup tests, setup selectors that have to be written only once. And if I have a different implementation, what happens? Well, there's another class that has a single message that sends a single different message and it has a single different tag. Big difference, as you can see, replacing times with plus is good. But there's something going on here. All of this lives in a unit and there has to be all this work and all this adaptation and just you saw the code, that didn't have an explicit evaluation with context for what's going on and so these parameters being passed around, etc. Well, it would be nice to get rid of that, and there's more than that. For example, besides extending it, that it can be difficult at times, there's the thing that, well, many people implement logging facilities for ESUNet, and they are all different. And while I have not checked every single one of them, chances are there are going to be modifications on top of ESUNet code. So now they're not compatible with each other either. And, well, as we saw, ESUNet VM and the hash analysis tool point to some of these efficiencies. So about December last year, I had, maybe earlier, whatever, but I had this realization that what I had to do for myself and for my own sanity, since I was making all these testing tools and things, was to make a new framework that would solve, at least to my impression, these problems that we've been talking about here. And this one is called assessments. So this is what I've been blogging about all this time. Oh, sorry, I guess whatever. So this is how it's going to run. If you remember, right, we have this test case class and a whole bunch of instances are created and then they get put in a test suite. And then they get categorized, in errors, failures, and passes, like that. And as we saw, there's no evaluation context and there's all these missing pieces. And one could actually go further and say, hold on, so what's this? Right? What's going on here? Why is it necessary to create an instance of test case and keep it around to run a test? So, yeah, this is fine. At one point I was talking about this to my sister. Actually, this is fine. I was moving, right? And I was driving my truck, my car being towed. And since I had nothing better to talk about with my sister, because we had already exhausted all the topics of conversation, I started telling her about students and assessments. And because she doesn't know anything about programming, I came up with this metaphor to make it easier to explain. So what I felt was going on is that, let's say you're taking a quiz. You give a quiz to people, like a questionnaire. Well, you know how that goes. You have a page with all the questions, right? And then you give that to somebody, and somebody checks off all these things, and then they give you back the piece of paper. So in that model, how does that look? Well, that looks like, well, there is a list of questions, but let's say the list has 50 questions, and I'm going to give that to Georg to answer the questions, because he's looking. So in ESUNet, what happens is, well, I don't give Georg the list. Rather, I keep the list apart, I make 50 photocopies, I check on each of the photocopies. Well, the first photocopy is for question 1, the second photocopy is for question 2, the third photocopy is for question 3, and so on. And then I give 50 pieces of paper to Georg, so he can check on each piece of paper that has the 50 questions, question 1, page, question 2, page. What's going on? Why? As we saw, more slides to delete. In assessments, it's slightly different. There is a checklist, which would be the equivalent of test case. And a checklist models the piece of paper with all the questions. So for instance, it models the idea of, these are the questions related to something. Or this is like questionnaire A. But they are not instantiated for the purposes of running. What is instantiated instead is this thing called a check. And a check is an object that models a single question. Then an assessment, which would be the equivalent of test suite, is a collection of checks. Now these checks, of course, know the checklist because they know how to run themselves and so on, but there's no longer the need to instantiate a checklist, just move a question around. in the same way that in ESUG it was necessary to instantiate a test case to move a question around. And in fact, the poor test case even had the question marked in it because it had an instance variable called test selector. So, in this case, while these things know the test selector, it's not necessary to instantiate that until much later, until it's actually necessary to answer the question. Now, once I have an assessment with all these checks, there is an evaluation context. And because there is an evaluation context, it makes sense to have a result policy. Now, and the result policy is the one that is in charge of collecting the assessment results as the assessment is running. And because it's a composite, you can tag on any arbitrary logging you want. And also because it's a composite, you can extend it without touching the coding assessments. Just provide an object. And if you don't like the result policy that is provided with assessments, well, that's okay. Because if you provide anything that is polymorphic with it, the assessment evaluation context doesn't care, and the checks don't care. Now, how does this assessment result look like? Well, right, so it is, in a way, a dictionary of, well, you know, that type of result, these checks gave that type of result, and since the checks know the checklist, you know where they came from. But they are classified in this manner, as opposed to with instance variables. So if you add more check results, you don't need to add instance variables and start, you know, overriding coding assessments just because you wanted more results. You just create another subclass of abstract results. So there you can see all the types of results that assessments currently supports. So there's the ones for benchmark, the error, the failure, the validation failure, the notice, the pass, a pass from a benchmark test, and also results for what happened to the prerequisites, meaning the test resources. Because in ESUG, it's not immediately clear if you get an error that came from a test or from a test resource. And in this case, it's expressed explicitly in code. This is what happened, and where and why. That's how they are classified. I think this is kind of neat. So the classification tag, this is on the instance side, right? So the classification tag for any result is its class. And the moment we have that, then the assessment result can classify results by class. So no longer we need, you know, instance variables and all these things. So this is how a check looks like. So a check has a receiver and a selector and some arguments. Also note that by arguments, then we can actually send tests with arguments. We are no longer limited to unary selectors anymore. So the receiver is usually the checklist class. Usually, not always. But usually it's that. And then there's selector the arguments, and then there's something else. There's something called execution policy. Why did this thing appear here? Well, because it's not the same to run a test and collect a result, or debug it, in which case I don't really care about the result, just open me a debugger somehow. Or let it run, and this time don't handle any exceptions, so if anything goes unhandled, I want a debugger. Instead of having all this code hard-coded somewhere, so if somebody in the future, you know, wants to change things and things, no, this is delegated to the execution policy. And this is great, because now the execution policy can modify how exception handling works, but without touching code, but just by providing a new mechanism, as opposed to going and hardwiring something. So how do this, you know, all this exception handling work? Well, again, we have, you know, polymorphic exception handlers, and there you can see, you know, oh, that's what happens when you evaluate something. That's what happens when you evaluate a prerequisite. That's what happens when you run something to failure, and so on. And you can see they occurred while evaluating, blah, 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 in the context of, like we saw in the CVM. Well, here comes the interesting part. But, so checks have execution policies, right? So they can actually teach them how they need to run. What can we do with this? Well, here's the check execution policy. And as you can see, or not, there's execution policies for ESUG VM, for ESUG 2, for ESUG, and for assessments itself. So this thing knows how to run testing any of those frameworks. How can it do it? Because it implements exactly what messages need to be sent to accomplish what. And now that this is pluggable, one can go and make a new subclass of it and say, well, here's how you run tests in this framework. Here's how you run tests in this framework. So if you're in this unit, that's right. If you're in this unit, I'm sorry for you. Couldn't help it, sorry. So if you're in this unit, create an instance of the receiver of the check. First, send it setup, then send it the selector with no arguments, because in this case, tests don't take any arguments, and then send it here down. And furthermore, you can actually teach it how to react to different exceptions. So for example, well, we'll see an example here. So here's how you run a check by default. So this would be the assessment execution policy. So there it says, well, the check passed is basic performed, which essentially is all this thing I told you about. And then if it didn't pass, then to that. And if it passed, then raise a pass notification. That's cool for assessments. Now, for CVM benchmarks, which, as you remember, they had all these multiple setup selectors. Well, it's really simple now, because if I know how to run one, then I know how to run many. So all scenarios perform super, basically. That's what it does. So, for all the test selector, for all the setup selectors, well, with the first one, super. With the second one, super. With the third one, super. This is cool, because now you get to refactor code all you want across these two. And for unit 2, well, unit 2 has its own exception for failures. Now, assessments may know nothing about this, but it doesn't matter, because exception handling is going to come back to here thanks to polymorphism. And because of that, I can say, well, if it is that kind of failure notification, so if it is an unit 2 notification, then handle it by, I think the method is not there. No, it's not. But handle it by raising another type of exception. So now you can teach it how to react in its own terms to exceptions raised by somebody else. Now, all of this is great, but, well, there's something missing, right? There's all these hierarchies of test case out there. For SUnit, we have subclasses of test case. For SUnit VM, we have subclasses of abstract test case. And for SUnit 2, we have subclasses of test case, but it's a test case that lives in a different namespace. Yeah, that is good. But see, this test case doesn't belong. So really, there's like these three hierarchies of tests, and it'd be ideal if we didn't have to rewrite any code, because all these tests have value, and it would be kind of pointless to have assessments in the interaction of assessments to cause all these tests to become obsolete. So a way to get around that is with metaclasses. Because again, I wish I had classes in a quote-unquote sensible hierarchy, and they all had a quote-unquote sensible behavior from point of view of assessments. I don't have them, I don't want to create code, I can't touch the code, therefore I create the classes myself. So how does that work? Well, the instance side is polymorphic with the class side of checklist, so it knows how to, well, give me all the checks and blah, 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 all that kind of stuff. And the instance side is also polymorphic with classes. So it knows, oh, this is the class to impersonate, these are my superclasses, and these are my subclasses. New creates an instance of the class being impersonated. Here's how the metaclasses are bridged. So for example, each bridge has a root checklist. That has a subclass that is a metaclass, and the metaclass makes more metaclasses, starting with this target class here. And that's how you can try to decorate classes with behavior without touching anything. Now this is beautiful. This is the creation method for these metaclasses. The method is called pretend to be a class subclass from a superclass. So, okay, so how does that? Well, this is my new metaclass for the test case root. That's for the SUnit bridge, right? So, pretend to be the root of test class subclass for myself. That's a class that doesn't exist. Well, it doesn't matter. I can do that. And how are the subclasses created? Well, again, you know, for the real subclasses up there, then again, pretend. Does this work? So here we have a checklist evaluator. The checklist evaluator would be the test runner for SUnit. And as you can see here, there's the SUnit bridge. There's the benchmark doesn't have anything, and this is actual native assessments checklists. Here are the assessment self-checks. And notice that now you get a new evaluation result window, and this is great because if you get failures here, then you can click on reevaluate result each time you change the code, and then you can see your progress, but without having to, touch this. This is the size of the code. This is also generated via assessments. These are the metrics that we've been posting on my blog. Has so many methods, so many classes, and this is the average. So assessments right now have about 6.8 methods per class. Okay, so let's run some SUnit. Why not, right? Oh, we can run a SUnit benchmark. Let's see. This is the test for the native stack. This is the one for string. I don't know. This. So here we have 48 passes for all these things. This is for complex conditions. So you could come here and say, well, I want to debug that. And the debug you get is a debugger in its own stack. You see no frame, no stuff from assessments at all because a new process is created for this. So you're just seeing at the debug output. So you can debug and write the failure, that's the usual thing. And that actually just ran SUnit test cases natively. It's not using the SUnit framework at all, and it didn't touch the test cases to do that. So, Steph told me I don't have much time left, so I will cut it short here. But basically, that's assessments, and that's what I wanted to talk about. Any questions? Or no questions?
Is it the payload now?
Yes, it's in the public store repository. The bundle name is assessments. What's that, sorry?
The license.
Feel free to use it. It's pretty much free. I don't care. I did it on my own time. I did it for myself. If you use it, great. If not, that's good too. I'm not a friend of licenses. I mean, I went through that enough with it. So, well, okay, I'll talk to you regarding licenses and I'll put a license on. Something else says feel free or whatever. Any other questions?